Good morning, everybody. My name is Giovanni Govoni, and I'm going to show you the proposal from Altanova Group for a diagnostic and condition monitoring of a medium voltage switchgear. This presentation is an overview about the three typical solutions starting from the heritage of the Altanova Group history to the latest technology developed in this recent period. Okay, just a brief summary as an outline of this webinar. I'm going to introduce with a few words about the Altanova Group, the reason to monitor medium voltage switchgears, and then we will go into more detail about this typical solution provided by Intelliso, that is a branch of Altanova, and TechImp, that is another branch of Altanova. And last part of this webinar will be dedicated to questions and answers. Okay, about Altanova Group, I don't know if someone is already aware, but just a few words. It is very important to add. And it's important to notice that we are a leading company in the field of advanced condition assessment technologies. Altanova is a group of three strong and long experienced companies in the market of testing and monitoring systems. One of these company is ISA. Another one is TechImp, and Intelliso is the third one. We provide solutions covering the full range of diagnostic tools needed for a practical application in an electrical system. And as you can see below, when we mention and when we talk about the full range of diagnostic, we can cover all the typical assets in terms of monitoring that are part of our market field of application. Altanova Group has three main headquarters. One is in Taino, in the north of Italy, and is the oldest company of the group, founded in 1938. ISA is the high specified technology provider for testing instruments. Another one is founded in 1999, is in Bologna, in Italy also. And last one acquired just recently, and now is a part of the group, founded in 2011 in a headquarters in US. Few details about the group. The three headquarters, as I said, two based in Italy and one in Massachusetts in the United States. We have 8 regional offices located in France, Germany, Emirates, India, Singapore, US, Panama, and Brazil. We have over 100 international distributors. And for the people that now are connected, I want to receive local support, immediate reply, counting on the same time zone, and sales support as well. They can refer to the web page and Altanova Group as the local distributor and list of distributors. All the distributors, I would say that they are high qualified in order to provide the proper support for the typical request that they can receive from the market. Of course, we are also service provider, worldwide expert team based in Italy, Germany, US, and India. And we have 3 research and development departments, of course, based in the related headquarters for offline, I'm referring to ISA in particular, and online competence on medium voltage and high voltage market. Actually, the main philosophy and the policy of the company as Altanova Group is to increase the grid reliability in order to guarantee the best service for the user and for the consumer. This is what we can resume our mission. Okay, going ahead with the summary and the outline, we are now touching why monitoring the medium voltage switchgear. The reasons are the driver that answer to the question why we should monitor a medium voltage switchgear. Actually, it's quite easy to reply because of the energy demand in the high density populated area is very high and constantly increasing. In fact, you have energy increasing demand from the industries, from the houses, from the hospitals, and from the transportation as well. The energy distribution is essential and cannot be stopped anytime. Of course, we have to also investigate what there is beyond the loss of the circuit breaker and the switchgear. Could be an ignition source, a catastrophic failure of controlled equipment, and also, of course, that maybe can touch more the supplier and the utilities, a business interruption. We can resume the losses beyond the loss of the circuit breaker and the switchgear with this graph that show actually in very simple percentage that the equipment damages is not the biggest part of losses, and also the fire containment that is actually to recover a disaster situation. But the most important losses and that can also worry the supplier, the private supplier or the utility is the business interruption. Mechanical failures represent about 30% of the overall failures. But the insulation failures span from 26% to 44%, including other old switchgear components. So if you can refer to this graph, you can see the insulation discharge cover almost 26% and mechanical 30%. The Altanova Group solution can cover and predict failure and malfunctionalities due to the cable termination discharge and the defect of insulation. That means that we can cover the biggest part of this graph and increase the reliability of the system, and also the cost optimization in order to avoid the business loss. Here you can see a few pictures about cases of failure and consequences. On the left, you have this thermal breakdown and how it appears after a failure. We have insulation defects that can cause this, and also surface discharge. Let's now talk about the traditional monitoring method. The traditional monitoring method actually review to have few spot measurement on a year time. That means basically could be twice per year or even once per year. That is the history of the maintenance plan from the utility or from the private producer of energy. But of course, to have the first spot measurement in the first half of the year and the second spot measurement as per maintenance plan in the second part of the years is not covering actually what could be in the between. And then everything that can happen in the between can also bring to a failure. To have continuous online monitoring, That means that the measurement is available 24/7. The measurement made inside the cubicle or outside, depends by technology, can provide alarms based on trends and does not require skilled operator. Basically, we are used to say that the monitoring system is looking the asset for the operator, is the eye of the operator on the asset. Now let's see which are the main causes of failure that can bring to energy loss and business loss. About thermal breakdown, typically the switchgear is composed by a bus bar, a cable termination, and a bolt that connect together. Due to the load current and maybe also to a weak tightening of this bolt, you can have a temperature increasing. Then, of course, this temperature increasing is if it is out of control, because, for example, the load current persists, can bring to a failure. Another cause of failure could be, for example, too high load current. So that means all the three, cable termination and the bus bar, are overstressed and the temperature is rising day by day. So that means that too high current, if it is not controlled, can bring to a failure again. Then for another typical situation is under normal operating voltage and normal operating condition, but it could be an insulation failure or insulation defects inside the material that can bring to a failure and service interruption as well. Now let's see which are the solution of the group to prevent and monitor actually the situation in order to avoid any failure or breakdown or service interruption. Starting from IntelliSaw, we are now having a look to the system composition. The system is basically composed by sensors for the hotspot, the sensor for the humidity and the temperature, because sometimes the failure and in the breakdown can be correlated by the environment condition and the hotspot together. There is an antenna that is also not only antenna, but also a partial discharge detector that is actually operating under the same principle. A reader and a local HMI that is actually the brain of the system. You need an antenna in this system composition because the sensors are wireless. The typical system layout for the monitoring of the IntelliSaw is composed by the sensor that is directly applied on the termination of the cable or the starting part of the bus bar. Typically is a bolt, under the bolt, and inside the medium voltage compartment. The antenna for the hotspot temperature sensor and also as a partial discharge detector is also installed inside the medium voltage compartment by a magnetic that is put behind the antenna. The humidity and temperature ambient sensor is also put inside the medium voltage compartment. Regarding the reader and the local HMI, only the local HMI, this is typically installed on the low voltage compartment. There, in this local HMI, you can also, of course, read all the parameters into different graph. Later, we show it as a few example, as a numeric format or also graph format. One possible realization, a layout of the system, is to have, for example, these 3 medium voltage switchgear on a line, and then you, the typical installation, you can notice there are all the wireless sensors inside the medium voltage compartment, the antenna, and the temperature and humidity sensor at the bottom of the medium voltage compartment. The reader is located in another panel rather than the local HMI, and then all is connected together. Once the system becomes more populated and the monitoring system requires to monitor more medium voltage panels, of course, you can refer to only one HMI, local HMI, and then connect all the other medium voltage switchgear through the reader and the related antennas and sensors. Everything, of course, from the HMI can be connected to an RTU, and using the standard industrial protocol, for example, Modbus, the information are delivered to the control room, where there is the main SCADA for the operator to check the status of all medium voltage switchgear. In this picture, there is a real example of installation of the system. You can see here, there is the circuit breaker input, and you can see here there are installed the hotspot sensors, wireless, as I said, and these sensors are communicating with this antenna interface. On the circuit breaker output, there are other 3 wireless sensors that are connected to the antenna number 2 on the bottom side. And here there is the humidity sensor. Everything is connected. So the question is, how far can we go with this sensor, since they are counting of wireless technology? There are not only one type of sensor, there are several types of sensor. Basically, the working principle and the technology inside is the same, but they are differentiating according to the size, because inside the medium voltage compartment could be some size and dimension constraint. So in order to satisfy this requirement, the company has designed different size of this sensor. The standard profile sensor, wireless sensor, is typically mounted on the bolt, under the bolt as installation, and cover up to 2 meters distance from the antenna interface. There is another sensor, and it's called low profile, and addressed to the height and space constraint, as I said, of medium voltage, or even for the low voltage aspect. It is suitable for installation directly on the breaker arms, and it can cover up to 50 centimeters. The reader on the bottom part of this slide is connected to RF cable through an RF cable to the camera interface, and it could be maximum 7 meters length. For other application of monitoring, Intellisom also offer a so-called closed couple sensor, CC sensor. They are addressed for space constraints of low voltage assets. There are multiple physical design, but they are not wireless. This is the main difference between the standard medium voltage sensor. The maximum distance covered between the reader and this CC sensor is 7 meters, and they are connected to a RF cable. These are other picture of installation for the CC sensors that you can see here and here, but also from the low profile sensor. As you can see in this application, you have space constraint. They are mounted using this plastic belt in order to fix. And here, as you can see, they are connected through a standard RF cable. Few words about the measurement principles of this system. Basically, we take as an example the standard IntelliSO sensor for the medium voltage compartment. This sensor is using the SAW technology, the so-called SAW technology, that means surface acoustic wave. To simplify the principle of this system, we could say that the antenna, the camera interface, is continuously sending a signal to the sensor that we call a stimulus. Okay, everything you have to imagine, everything inside the medium voltage compartment. This stimulus reach actually the sensor that you can see on the left side, and the sensor for the crystal and the technology that has inside actually reply with the two different resonance frequency. Basically, these two frequencies are with a certain precise number, and the difference of frequencies of these two frequencies represent actually the temperature measurement. This actually because the crystal that has inside is a technology characteristic and behavior that, according to the temperature, has a different frequency, resonator frequency. This means actually that with the higher temperature, the material inside the sensor is dilating, and also face some restriction when the temperature go lower. So it's the typical behavior of the crystal inside according to the temperature variation. And this difference is representing actually the temperature measurement. One of the plus to have this passive sensor and wireless, the passive sensor actually means higher reliability and also extended lifetime. Another measurement that IntelliSO system is providing is also able to detect the partial discharge coming, for example, from the cable. In fact, the events can cause a broadband UHF emission that are picked up by the air interface. This antenna is designed to receive this signal coming from the PD source in three different bandwidth: 300 megahertz, 600 megahertz, or 1002 megahertz as a central bandwidth. Actually, these three different bandwidth are because inside a substation or inside this environment, there are too many signals coming from the high frequency. So it is also possible to detect and also to differentiate the signal coming in the different free bandwidth. About the monitoring system capabilities, we also mentioned that the system settings, of course, is possible for the operator to make the configuration. Collection the data from the readers, the data elaboration, the data trending and storage, and providing the alarm. From the HMI, it's called CAM5. CAM5 is also possible to read, of course, the temperature and the relative humidity on a numeric scale, numeric format, but also in a graphic form. Graphical data can show the temperature on the time baseline, and also the trend of the temperature according to the timeline. The alarms from the CAM5 can be sent using a GSM router, and also and reach the operator through email, but also can be sent using the industrial protocol through a SCADA or RTU to the control room, or locally by the dry contacts. Now, about the TechImp monitoring solution, we move to another technology and to another solution proposed by Altanova. And I will introduce you about the Falcon device, that is the partial discharge monitoring system for the medium voltage cables. Actually, this unit has the benefit that is fully automatic. The measurement is of the partial discharge is done through the sensor located on a cable termination, basically. The storage is inside the unit and can be up to 2 years data inside the unit. The analysis of the unit is completely automatic and can recognize the critical issue and its evolution. The alarms are provided per the standard communication tools like the other system they introduced, but later part we will go into more detail. Okay. Basically, one of the highlight of the Falcon unit is how much is user friendly, and in fact can provide the alarming given with the different levels of severity, from good of critical. The principle is basically that you can have your many Falcon installed and in order to monitor in different medium voltage cable, and in a very simple way you can connect one by one and have all in your computer or in your SCADA or whatever, and control one by one the situation of the medium voltage cable. The alarm is also provided through email or dry contact or through a SCADA. The cable conditions are immediately available upon login with clear indication in case you receive a notification there is an issue on your cable. The operator does not need any high-level skills to manage the Falcon. This is because the Falcon unit was specifically designed in order to be very user-friendly, and in order to that utility does not need the operator skill. The system is composed by the unit, basically, sensors, synchronization. I mean, we can provide also the synchronization tool, but it's typically available at site, using, for example, Rikoski coil. And the software is totally inside the unit, so it's not needed any additional software. In fact, Falcon is a plug-and-play device that can be installed with a few simple operations. The unit is configured itself automatically, and once powered, it is immediately operational. Here on the right side, you can see an example of installation. As I mentioned just a while ago, the network integration is a part of the unit, and Falcon can be integrated into existing monitoring system through, for example, the IEC 61850 protocol. Now, a few details about the unit and its setup. The unit has the power supply connectors, the dry contact on the front panel, 2 LAN for the communication. That means that you can put many Falcon in a daisy chain layout, or use one single port to connect your laptop to immediately check the status of the asset. There is a channel for the synchronization, and the one single channel for the partial discharge detection, and this has to be connected to the sensor. Okay, the typical installation of the Falcon unit is again using with the magnets, but it also can be installed using the DIN guide. If we want to compare, sorry if I go back, if we want to compare the installation of the Falcon unit with the IntelliSO that I mentioned before, this Falcon unit is important to note that is not intrusive and is designed to detect the partial discharge rather than the humidity, and it is installed outside the compartment of the switchgear. In fact, the typical example of installation of the sensor in this slide we are mentioning, the HFCT, that is the high frequency current transformer. It could be placed around the grounded shield in 2 different layouts. For example, if we have the 3 single core cable, it could be used the 3 ground connection inside the same sensor, or even if there are 3 core cable, use the 1 ground connection into 1 single HFCT. There are some layout that also requires to have where they are available, these 3 single core cable are required to have 3 sensors, 1 per each ground link connection. This allows to the user to identify which cable has more amplitude of PD and recognize immediately which one is affected by the partial discharge. Another setup is to use the TV antenna placed on the metal enclosure of the panel. And this is highlight again that this technology is totally non-intrusive. Regarding the sensor, some example of installation also on the medium voltage transformer. You can see here there is the HFCT to this ground connection and the TV in this part. Of course, the TV has to be placed in the part of the compartment that is not shielded. Basically, the 2 sensors I already mentioned, the typical application is the high frequency current transformer that are installed to the medium voltage cable termination, and the TEV antenna on the enclosure, directly on the enclosure. Just a few words about explain what is the process for the automatic function of the unit. Basically, the unit is always hearing the asset, of course, according to the interval acquisition time that is configurable on the unit. And once there is this automatic acquisition process, then the unit does the cluster separation in the TF map. Of course, it could be worth to go into more details about the TF map and the patent technology of TechImp. It could be also, if you are interested, is someone interested during this webinar, we can set a proper explanation or provide more details. Then when the cluster and the separation inside this TF map is done, the Falcon unit start an algorithm to check if this phenomenon is persistent inside the equipment or is just a sporadic event. After that, there is a process for alarm evaluation. And then the cycle repeats again. The acquisition actually, for every fixed time interval, the Falcon automatically performs an acquisition. During this acquisition, the Falcon is able to automatically choose, based on the amplitude or the repetition rate, the better value in order to identify the PD range. So in order to auto-scale, it's called to auto-scale the PRPD pattern. And the full scale can vary from 0.1 volt up to 10 volt. This is according to the environment and the equipment under test. And also is automatically providing the trigger for the pattern. After this, once the acquisition has been performed, a dedicated algorithm separates the different clusters present in the TF map. So that means that this actually from the PRPD pattern acquired, there is algorithm that transfer the measurement into equivalent time and frequency a graph in order to do a proper clusterization. After the cluster separation, the Falcon verifies if the cluster present in an acquisition are still present in the subsequent acquisition. This operation is done basically to avoid false alarm, because you can, and that in particular in a medium voltage environment, this phenomena can appear and disappear. So it's very important to have a reliable monitoring system to select which are persistent phenomena and which are only sporadic. This result basically, after all the algorithm, all the process done by the unit are shown in the web app, and the web app shows only the persistent phenomena. The sporadic events are not shown at all. The web app is one of the benefit of the unit, because allows to any operator that has laptop or even a smartphone with a simple browser to go inside the unit and check on a different level of detail about the status of the equipment under test. The alarms provided by the unit, of course, there are local alarm, just looking at the frame that can be provided by LED, according to, of course, a very simple layout. Green, no activity. Red, there is an activity and is requiring inspection. Or also using dry contact. And the last level is connecting through the web application using the Ethernet cable and check all the functionality and see what is the severity of the alarm. The interface, as we mentioned, of the
the software application has different pages. The home page actually shows this color scale of PD detected. There is another page related to the alarm list, relevant to the partial discharge activity based on a historic of the unit, a list of system notification, and to go in more detail, there is the visualization of trending of the most important statistical parameters: amplitude, repetition rate, and alarms. This is an example of the trend visualization and the interface of the unit, max repetition rate. For each dot that you can see on this graph, you can perform the analysis using the PRPD pattern or the TF map. The trends are basically counting of Qmax, repetition rate, synchronism frequency, and synchronism amplitude. These are different colors for each different persistent phenomena. The unit can acquire up to 4 different persistent phenomena, separate them in different trend, and then the operator, this is for more skilled operator, can perform the analysis and have some conclusion in terms to do some assessment on the asset. The last equipment as a further development on Falcon is called Falcon Mark II. This is the ultimate technology realized by TechImp in this 2020. The Falcon Mark II is influenced by many years of experience, and it exploits a full patented technology as well as expertise gathered in the years of development of partial discharge monitoring platform. Basically, the experience is balanced with a state-of-the-art platform able to offer a computational power for the algorithms and speed to process data. This Falcon Mark II unit basically combines measurement done with different technology and types. We are talking actually of a unit that are merging different sensor technology and measurement. In fact, the Falcon Mark II can get a signal from UHF, from electromagnetic field wave, from acoustic wave, can have also humidity measurement, temperature measurement, and actually it has the automatic identification as for the Falcon Mark I. And also it's important to note that like the Falcon has the communication facility like network integration using IC 61850. Some insight. The Falcon Mark II is basically a partial discharge, is an evolution of the partial discharge acquisition instruments for the medium voltage asset. It comes in a 19 inches rack, and it is a modular system that can host up to 10 boards, and is mounted in 6-unit rack, 6-unit high rack. Each board can acquire up to 2 ultra-wide bandwidth, for example, for the partial discharge, typically by means the HFCT or the TEV, plus 2 ultrasonic PD channel per slot. That means in total, up to 40 partial discharge channel for each unit. This unit, the Falcon Mark II, acquires a full signal waveform and it processes them exploiting the patented TF map technology, able to increase the signal to noise ratio and separate different signal sources. Also here, the main sensor used are HFCT installed on the cable closest to the switchgear cable out. For the TV, that is the sensor with a special design to maximize the sensitivity and easy of installation directly on the panels of the medium voltage compartment. About the ultrasonic sensor, Altanova can provide two different types of ultrasonic, and basically they are installed on the bottom of the switchgear cable box compartment, aims to cover any potential discharge coming from the cable termination. The airborne is very sensitive piezoelectric sensor, and the contact sensor works on a resonant circuit principle. Both of these two sensors has a center frequency of 40 kHz. Regarding the temperature monitoring features of the Falcon Mark II, there is another rack, 19 inches size, to host in the same enclosure, that can detect they can be connected up to 40 contact temperature channels. Temperature sensor. This actually has a consistency with the Falcon unit that can monitor up to 40 partial discharge channels. So they are designed to put together in the same cabinet. This is an example of the system, how it appears on a real installation. There is a cabinet where there is a switch to connect all the unit and have an easy interface for the center, the Falcon Mark II, and the data logger also. Plus, of course, the power supply to provide the power supply to all the units inside the same cabinet, the fan also for cooling the system, and this is Altanova design for a real installation at the substation. Basically, some highlights of the system: the centralized substation installation is inside a standard 19 inches rack. The instrument is innovative for the partial discharge recording. The ultra-wideband fast integrated processing capability, automatic partial discharge data acquisition procedure. So again, the system is totally automatic. It can provide reliable alarms based on the trending of every phenomenon. And as we mentioned at the beginning, it is a comprehensive solution that can integrate other modules and systems. About the software interface, with the typical installation of the Falcon Mark II, you will have two different software interface. First one, that is shown in this slide, is the local interface. That means the software embedded inside the unit. Each unit, each Falcon Mark II is very user-friendly and immediate connection through your laptop with the web browser, and in order to access, as for the Falcon Mark I, to the software that provide immediate status of your equipment under test. This is the same platform actually of a Falcon with the function divided per each channel accordingly. That means you can see here you have the status, in this particular case is screen for the HFCT or TV, and then ultrasonic, this actually is for the contact type or for the airborne type. If going to this particular channel, you will have a dedicated page with the trending and information about the state. The principle and the function are exactly the same for the Falcon Mark II as for the Falcon Mark I, but in this case are 4 more channels. The typical installation of the Falcon Mark II is for large number of medium voltage panel monitoring, and requires is so-called TechImp SCADA, this SCADA software that is a solution that is able to centralize event summary list, is able to set 2 levels of alarms by magnitude, threshold, etc. Is able to send out via mail the alarm, to set the acquisition interval of each instrument to 30 minutes up to 2 minutes. This is actually depends by the customer requirement. Show the magnitude and trending of the signal recorded through a TV, HFCT, or ultrasonic. Is able to show the PRPD pattern for each recorded measurement for TV and HFCT, even from the control room. And also some HFCT also we mentioned, as well as TV, is able to remote capture at least 4 pulse waveform. And the main page of the proposed web-based HMIs typically is a georeferenciation of the interested area city. So basically on the main page, we are used to provide this map of the city where there are substation as a first level, substation with the system installed. Each accessory is identified with a specific logo. In the case of normal PD activity, the logo is thick and gray. In case of first order of alarm, is represented by the yellow. And of course, when it comes to critical, the color is marked as red. Moving from the regional details, I mean, from the city area main page, is possible to access to all the substation detail and a single switchgear. In this level, the ambient temperature and humidity, and of course the contact temperature, are reported here. And since they are on a numeric value, they are immediately represented on the page. For each phenomenon, also in this software, it is possible to display the relevant trending. Other few words about the SCADA. The system automatically stores a few waveforms, basically 4, per each acquisition. Waveforms are automatically stored in the database each time. These are 2 examples of PRPD pattern, TF map, and the 4 waveforms. When is required, the operator can save acquired waveform, save waveform, or audio file. The waveform are stored in a CSV file, while the audio file are in a WAV file. This is how it looks like, the audio file and the waveform saved inside the SCADA. To summarize as the conclusion, the Falcon family provides early diagnosis of the faults to the installation defects, optimization of energy productivity and reliability, extension of the asset life cycle, optimization of maintenance plan, no disconnection, no inactivity or interruption of energy, and it is 100% safe as a non-intrusive system. If you want to compare the 2 different Falcon, okay, it's mentioned that Falcon no need specific skills, no need to analyze data, easy to install, automatic configuration, automatic alarms, no specific expertise for commissioning, and it is a low cost. While the Falcon Mark II provides typically a global monitoring due to the merge of different sensor and measurement value, is fully customizable, is modular, provide the waveform and audio acquisition, is also providing no false positives because the main acquisition policy is the same. It also satisfies the cybersecurity requirement, and it is basically designed for a very large-scale monitoring application. And it had also the network integration. Of course, in this presentation, due to the time restriction, it's not possible to go in detail of each system shown. It was just an overview of the system. For any further questions or request of clarification, we kindly ask you to send to me directly an email. If it's needed, also we can fix a meeting in order to explain the main function, or which are the typical application, and also provide more information about all the system wherever is required. I think now could be the time for the question and answer. I will ask to my colleague Marco if there are some questions. We can try to satisfy and reply.
Hello, Giovanni. Thanks for your presentation. Yes, we have several questions here. I already replied to all of them. Some can be of interest for all the audience. Let me start for the first one. The first one is, how are the sensor powered? You already mentioned that this temperature sensor, I'm referring to the IntelliSO system, are completely passive. So no power supply is required for that sensors. And there is another question regarding to the same matter, it was, but does this mean that they need a minimum of current in the cable to run and communicate with the antenna? Again, the sensors are completely passive. They don't need any current inside the cables, and these sensors are stimulated by the antennas. So no need power, no need connection, no need current inside the cables.
Yeah, exactly.
Another question is for installing the medium voltage monitoring system in existing switchboards, how much time is required, and cost implications? Again, for this, normally the installation is very, very simple and can be normally performed by local crew. And in general, for all the audience, you can consider that in one working week, we can do the commissioning of about 20 switch gears. Another question is the following: is it possible to connect IntelliSO temperature sensor to all size and cable and bolts? The answer is yes. We have several sensor types with several and different dimensions, so that can be used of a variety of cable types and connections. Normally, no problems regarding this point. Another question is related to a contact, how we can have contact details of our India office. This is for all. You can use our, we suggest to use our Altanova website, go on contacts, and you can see our local offices and also all the contacts of our distributors. We'll email
of course,
and telephone numbers.
Of course, all the attendees will receive the PDF presentation. There are some indication about how to reach me and the other distributors, and then we will be glad to reply to any further question.
The last one, Giovanni, is the following: how long need to get good PD result in switchgears? My reply was, if you want to add more, we normally suggest you keep the system installed for a while. We mean some days or a few weeks in order to have a good assessment of basically the trends of the PD phenomena.
Yeah, of course. because it's the system will start from time 0 in the moment you install the system. So according to the trend increasing, actually the system has to detect if the situation is becoming worse day by day or it's stable. So it could take at least a few days.
This was the last one, probably just the last one to be more precise. How many temperature sensors type for IntelliSoft system we have? I think that also in this case we suggest to use our website where you can find all the documentation and the data sheet for all the sensor we have for the IntelliSoft platform, and for sure we are more than willing to reply to your further question by email. You can write to info@altanova-group.com or the sales channel as well.
Yeah.
I think that for now, this is more or less what we have here in our question panel. And thanks for your attention from my side, and thanks Giovanni also.
Thanks Marco. Thanks to all the attendees. We hope to receive some question from you or request of comment.
Bye-bye.
Bye.